welcome back. This is part two of the regular polygons, an area of regular polygons, and I wanted to go through, and this is where we ended off in the first video with finding the area of this triangle's, equilateral triangle's area, given that one of the sides was 14. So we're going to move on to another example. This one happens to be, it doesn't really look it, but we're going to pretend that it is a regular pentagon. So this is a regular pentagon. I need a little space here so I would be able to talk about my angles. So that's probably why it doesn't look so much like one. All right, so again, we're going to use the same rules as before. I want to first find theta, and theta again is this angle right here. There's my theta. And this is a regular polygon, so that means all of my side lengths are 10, and all of these angles are the same measure. So that's what I'm going to first focus on. Let me change my color back. So the formula that I am going to be using from first semester, first 9 weeks, is n minus 2 times 180 divided by n. N is the number of sides in your polygon. So in this problem, it's 5. So I'm going to substitute in 5, solve for the value that we get. And that is just coming. So 5 minus 2 is just 3. So I'm going to do 3 times 180 in my calculator. And we get 540. And I divide that with 5, and we get 108. Now, 108 is from that side to that side, so that whole angle is 108. But that's not how big theta is. Theta is always half of that. So 108 divided by 2 is 54. All right, so that's my theta, that's my 54. So there's step 1. The second thing that I'm going to do is now use trigonometry, because I have now a little triangle here. There's my right angle as the apothem hits the one of the sides is always at a 90 degrees. And my theta now is a 54. As in the last video, I talked about the side length. This apothem hits always at the midpoint of the side. So that means this portion of my side and this portion of my side are both the same length. So 10 divided by 2 portions is 5. All right, so I am solving for my apothem, which is this lowercase a in my formula. And my apothem using trig is opposite over adjacent. Opposite over adjacent is, like the last video, we use tangent. So tangent, I'm going to write an equation now that will help me solve for alpha. So we're going to have the tangent of 54 degrees is equal to the opposite over the adjacent. I'm going to use the calculator to solve that. Don't forget to make sure your mode is in degrees. 5 times the tangent of 54. And again, I always put the number and value in my fraction first. Otherwise, you get a weird wrong answer. So 5 times the tangent of 54 comes out to my A as my apothem as 6 point, I'm going to round to the thousandths place again, 882. This was a 1, and after that there was a 9, so I round up. All right, so step 2 is done. I found now the apothem. I go on to substituting and find my area. I'm going to change colors here to help me go to the end. So I'm going to substitute in all I know. My A is the number we just solved for, 882, and I have my perimeter. Now the perimeter is simply the sum of all the lengths around. Since the perimeter has 5 sides, each of the sides is 10, that means my perimeter is simply 5 times 10. So I'm going to put that in last. All right, so I'm now going to multiply just how it's written here. I'm going to type that very thing into my calculator. 1 divided by 2 times 6 point, parentheses, excuse me, parentheses, 6.882 times parentheses 50, and we get our area of 172.05. Since this unit is given and I'm dealing with area, I must use that same unit, but it's squared. Remember, area is length times width. It's 2 dimensions, so therefore I have a little 2 there. All right, let's go on to another problem. So, same steps, different shape. So, theta is right here in that problem. There's my theta. It's my little degree that I'm solving for. And this is a regular hexagon that's going to be given in the problem. And we are finding that first, that theta, then we will use trigonometry to find the apothem. However, in this problem, I am not given the outside side length. I'm actually given the radius to the circle. And let's pretend that the circle wasn't there. That side is still called the radius as long as it goes to the vertex here and from the center of your shape. That's called a radius. Okay, so that might help us to find our area at the very end. So we're going to have to find the perimeter of that hexagon by using trigonometry, or helping us anyway. All right, so let's get going. First, going to, let me change colors again, n minus 2 times 180 divided by n is 6 minus 2 times 180 divided by 6. Again, 6 minus 2 is 4. That's why I wrote 4. So in my calculator, I'm going to write 4 times 180 divided by 6, and that's simply 120 degrees. Now don't get confused. That's not how big theta is. That's how big the whole entire angle is. That's 120 degrees. Theta is always half of that. So that is 60 in this case. So I have a small triangle. Let's see if I can draw this a little crooked here. Theta is 60. I know my radius, which is located here in the picture. That is my hypotenuse. Well, how do I know that? It's opposite my 90 degrees. My hypotenuse is always located opposite the largest angle. Since 90 in a triangle, if my angle is 90, that is the largest angle. So there's my hypotenuse. So I'm going to use trigonometry to find my apothem. So opposite over hypotenuse is the sine function. And I have my opposite over hypotenuse. In my calculator, I'm going to type in 12 times sine of 30, or excuse me, sine of 60. And I get simply 12 times the sine of 60, making sure my mode is in degrees. I have my apothem given as 10.392. Again, I round to the thousandths place. The number after this is a 3, so I keep it as a 2. All right, so I have my apothem done. I also have theta done, and now I need to find the area of the polygon. Let me change colors here. My area is equal to half my apothem, which is 10.392. And that's going to be multiplied by my perimeter, but I really don't know what that perimeter is. So I'm going to have to find this side length, this portion right there, because that's going to be then multiplied by 2, which then I can multiply by 6 to get the perimeter. All right, so let's do that. I don't need the alpha. I'm going to, or my apothem here. I'm going to actually use my hypotenuse and my adjacent. So let's see, some other color. Blue sounds good. And my adjacent over hypotenuse, I'm going to use to find my perimeter. So adjacent over hypotenuse is my cosine. I'm going to write an equation to help me solve for, what would we call this? Let's call it x. The cosine of 60 degrees is equal to the adjacent over my hypotenuse. Using the calculator, 12 times the cosine of 60 is equal to x. So I'm going to type that in. 12 times the cosine of 60 degrees is a whole number, 6. All right, so if this side right here is 6, that means this portion of my side length is 6. That means the total is 12. So if each side of my hexagon is 12, my perimeter is 12 times 6. And we can find that out before we substitute in to find our area. And 12 times 6 is 72. You can certainly write the 72 here, or you can just leave it like that because you're looking for the area. And the area, then now we go back to our calculator, we divide in just what we see there. 1 divided by 2, parentheses, 10.392, end the parentheses, start a new one, and write 12 times 6, or you can write the 72. We still get the same answer of 374.112 as my area. And again, it doesn't give a unit here, so this would be units squared. If they gave some type of unit, it would be squared units. So again, please be careful with your perimeter here. We may have to calculate that before we put it into the formula. I hope this video helps you with area of regular polygons.